Hey everyone, for our final project, our group name is Drew's Fan Club, and for the Machine Learning and Artificial Intelligence project, my name is Brian Lolordo, and we are here with Kobo Hartman, Marshall De Leon Jr., and Sean Shojati, and we did our project for creating a Drewbot. So what we did was develop a machine learning based bot specifically designed to emulate our beloved teacher Drew and his mannerisms and how he spoke in class. We leveraged open AI's APIs and fine-tuning capabilities to learn from the transcripts from the recorded classes as well as the speedruns to create our model. Throughout our project, we used a number of technologies from the cleaning phase all the way through the machine learning and creating the bot, machine learning and AI, as well as the presentation and putting it all together. And we'll get into each of those technologies a little bit throughout the presentation later on. And without further ado, we're going to go into the story of Drewbot. Once upon a time, in a world of data science and analytics, four enthusiastic students, Brian, Kobo, Marshall, and Sean, embarked on an educational journey that would change their lives forever. Under the guidance of their amazing instructor, Drew, they dove deep into the realms of Python, SQL, data visualization, and the intricacies of machine learning and AI. Drew, with his unique blend of expertise and wit, not only taught them the technical skills, but also shared life lessons like the dangers of running late at night in San Francisco and the subtle art of avoiding overcharges. As their course neared its end, the students faced a bittersweet reality. The thought of no longer having Drew's guidance left them feeling both hopeless and defeated. Them, like a bolt of inspiration, a brilliant idea struck them. Why not create an AI version of Drew? A Drewbot that would perpetually be their mentor, their friend, there for them when they were lonely, or to tuck them into bed at night and read them a bedtime story. Eager to bring their idea to life, they collected every video recording of Drew from their classes. They painstakingly transcribed his lectures, captured his speech patterns, responses, and even his unique mannerisms. This treasure trove of data was then fed into OpenAI's advanced machine learning models. The anticipation was palpable as they waited for their Drewbot to come to life. Their initial excitement, however, turned to confusion when the bot, who named himself Chris, instead of Drew, delivered responses that were sometimes spot on, but other times nonsensical or incomplete, but still knew who Michelle was no matter the case. Undeterred and driven by the spirit of Drew, who has taught them never to give up, the students delved into refining their creation. They scoured for more data, feeding baby Drewbot with a richer, more comprehensive dataset, teaching it that his name was indeed Drew and not Chris. Their dedication paid off when OpenAI, like a beacon of hope, announced that Drew was finally ready. The moment of truth arrived as Brian tentatively asked, "Hi, what is your name?" "Hi, Brian. I missed you." "I'm Drewbot, of course. I told you setup was important."
So I will be talking about the cleaning process that we went through to get all of our data prepared for the OpenAI model. So we started with our raw data, which was all of the speed runs and class recordings that we've accumulated over the duration of our course. We ran the speed runs and the class recordings separately. We did the class recordings through a transcripts.com, and it was able to output our transcriptions with the speakers identified, which was very important for us because during our classes, it's not always just Drew talking. So we were able to tell it which voice was Drew, and it was able to keep track of him throughout the transcript. Once the transcripts were cleaned up and available to us, we tried to upload it directly basically as a text file to OpenAI, and the OpenAI did not like that format. So we spent some time looking at the different methods of uploading it, and we found that it needed to be in JSON format. So we tried, I believe, about 3 or 4 different formats of JSON before we were able to figure out the particular formatting, JSON-L, but even within that, a formatting called prompt completion. While we were working through the different JSON formats, there was even a moment in time while we were struggling with it that we were basically manually formatting the data and trying to upload it before we wrote an entire script to format our data, that we could just prove that the format was correct. We did a similar process for the speed runs, but it had to be tailored a little bit because it was just Drew speaking. You can see some examples of the before and after. So on this particular slide, we can see class recordings where there's different speakers. And then this is an example of what the format on the right here, what the format would need to look like for OpenAI to accept it. And it's very similar on the speedrun cleaning, except only one speaker. And so the cleaned data, of course, looks a little bit simpler. Once we had the cleaned JSON-Ls, we pushed them to the OpenAI servers. At that point, we began fine-tuning. Meanwhile, Sean was working on deployment.
Once our data has been cleaned, and while we're training it, we decided to do some visuals. Starting off with the commonly most used words by Drew in class. You'll notice here that Drew is obviously brought up a lot because we are asking him a lot of questions, with us data and some other words being used. Something that was interesting to us is the only name out of the class that was brought was Angel. In our speedrun data, you'll obviously notice that there aren't any other names being used. And going is the word commonly used in both speedruns and class, which was very interesting. We will upload both of these to Slack so everyone can get a closer look of the most commonly used words by Drew and the class. Now, after these visuals were complete, it was time to deploy our bot. Using HTML and JavaScript, we were able to use the API key given through OpenAI and connect with our HTML. We decided to deploy this locally for privacy reasons, obviously. You're welcome, Drew. We wanted a video recording of Drew, a video bot. So the DupDup was the website we used for that. Some of the challenges we ran into while trying to deploy our HTML was some security issues with the API that was quickly figured out. We also, every time pinged our API, it did cost us a little money, so we were very careful about how many times we pinged and how often we used our API. Some things we would love to do in the future is connect the actual visual bot to make it look and sound more like Drew and have a response with Drew's voice anytime you ask it a question. So with our HTML ready to go, we are pretty much now waiting for our data to get trained so we can connect the two and have our bot ready to go.
You all thought I was joking. You all thought I sat there, I said I have him doing it, and now you are, there's no way he's doing it. But I did it, and here's what we did. So we ran into some problems with the initial models. You see, like, here's a kind of problem, like, how are you? Good, not so bad. Do you like pie charts? Yeah, I love them. Love who doesn't hostages, love bind variables and all that sort. Not ideal, right? Obviously it loves pie charts, and that's a no-go. We don't want it to love pie charts. So the training data we used for this particular set was like a 2-to-1 ratio of classes, of just classes, right? So we did 2 classes in a row for training, and then we would do the third one for validation, and then another 2 for training, and another one for validation. And that's how we did this initial set, and we didn't really like it. We did a couple more iterations until we eventually threw the speed runs in there because we thought it would learn better if we gave it kind of one-on-one Drew just talking, so it would know how to form sentences a little better, because this is a little wonky. So once we mixed in the speed runs, it still wasn't quite where we wanted it. So what we ended up doing was mixing in a little bit of class recordings and back and forth conversation into the training data, and then made the validation mostly classes, like mostly back and forth. So OpenAI would get a really good sense of people talking to Drew and then Drew's like expected response. So we could kind of cross-reference it with the training data. And that's essentially like how the training takes place. You can see here where we've called the different models with the API key in our dashboard to talk to it and really test it out and really get the parameters set. One thing that's really frustrating is getting it exactly set to talk the best way possible. So if we go into Playground here, you'll see there's a lot of settings on the right. So we have like temperature. This says as it approaches 0, the model will become deterministic and repetitive. We have maximum length of tokens, or in this case, like sort of characters that will generate. We have like top P, which controls diversity. So like it says 0.5 means half of all likelihood weighted options are considered. And we have a frequency penalty that is pretty much decreases the model's likelihood to repeat the same line verbatim. And then we have presence penalty, which is how much to penalize new tokens. So it kind of makes it talk about new topics, which in this case we don't really want. These settings aren't accurate, but if we go into our VS Code here and our script, you'll see we did set it with the API for the dashboard. So it's not set here in Playground, but you'll see the parameters have kind of changed here for the code. Without further ado, here is our incredible dashboard.
Hello there. I'm Drew. How may I assist you today?
So you see we have this little video of Drew that plays when you open the site. Obviously it doesn't sound like Drew. As Sean mentioned, that was one of the technologies we would love to work on in the future. We messed around with 11 Labs a little bit to try and clone his voice. So we can ask us some questions here. We'll just start with like, how are you? Good, I'm doing well. I've been doing a lot of things, so I'm just going to share my screen. Yeah, Drew likes to talk about sharing his screen a lot. The bot kind of reflects that quite a bit. We'll ask it the classic question that we always trained it on. Every model had the same disdain for pie charts, so we'll see here. Let's see, we'll just ask it, do you like pie charts? No, that's great. Let's say, why are pie charts bad? It's not that they're bad, it's just that they're not like the best option for showing trends or distribution. So in this case, I want to show you, like, I want to demonstrate something that's pretty cool. So make sure if you're pretty advanced, you can see here that you can do D3 select and you can actually take a look at all these. I'm going to demonstrate this and show you like why pie charts are bad. So not a bad response if you remember that he's always demonstrating stuff. One thing that we would also love to expand on is, you know, like, visuals would be cool. The goal for Drewbot was to have something you could interact with and ask questions to. So the end goal would be for him to say this and then demonstrate why pie charts are bad, you know, have some sort of visual. I doubt that this model will have the same like response as it did the first one when we asked who its favorite student was. In that case, it was Michelle. That was pretty funny. We'll ask it who's your favorite student. We have it as a sense, oh, I don't know, I don't play favorites. Cool, which would probably be an actual response that Drew would give. So it's pretty cool. We like to throw personal questions at it that are particular to Drew. Although this is technically a like educational bot and a conversational bot, sometimes it'll remember that it's a bot and it'll say, you know, I don't live anywhere. But sometimes it will say California, which is pretty cool. I was really hoping that would happen. A couple times we've asked it to be more specific and it has said the Bay Area, which is also really cool. We haven't really fine-tuned it a lot. So this is like purely based off of the class training data and the validation like speedrun data. As I said, this is an educational bot, so I'll ask it a more specific educational question. Maybe it can help us out. What is the best way to web scrape data? We'll see what it says here. I would say like beautiful soup and requests, and it also depends on the website if they allow you to do that, but we'll try and find out, right? We're going to use the pandas to scrape the table, and then we'll talk about ways where you can get the data. So let's do a very simple example. I'm going to use this beautiful soup and request, and I'm going to import them first. So import, I'm going to use requests as an alias, just so you know, and blah, blah, blah. So, you know, it's still a little funky, but beautiful soup is a good answer. And then it kind of goes into an example, which again happens in class, so I can see where it's getting that from. But it would be cool to have it accompanied with maybe like a code snippet or, you know, something like that. So speaking of which, we can ask it, what is your name? And it says Drew. So pretty cool. Drewbot.